There is a powder so effective against garden pests that field trials in the 1940s recorded a 97% elimination rate within a single hour of application. It costs less than $1 per treatment. It leaves no chemical residue. And it has been sitting, largely forgotten, on the shelves of history while the global pesticide industry grew into a $90 billion annual market. How does something that works this well simply disappear? By the end of this video, you'll know exactly why and exactly how to use it. To understand what we're dealing with, we need to go back to the late 1930s. Farmers across North America and Europe were locked in an exhausting war with insects, aphids destroying entire cole crops, cucumber beetles tunneling through squash before it ever reached the vine, slugs reducing lettuce beds to nothing overnight. Chemical pesticides were available, but they were expensive, often toxic to livestock, and required specialist handling. For smallholder farmers, the people who actually fed their communities, there had to be another way. There was. And it had already been there for hundreds of millions of years. In the wheat-growing regions of Hungary and Germany, agricultural researchers in the 1930s began systematically documenting something that grain farmers had known intuitively for generations. Certain fine mineral dusts, when applied to stored grain, killed insects with near total reliability. The mechanism wasn't chemical at all. It was physical. And that distinction, as we'll see, is what makes it both extraordinary and commercially inconvenient. By 1938, American entomologist Dr. W.H. Pfatt at the University of Wyoming had begun formal research into diatomaceous earth, a sedimentary rock formed from the fossilized skeletal remains of single-celled aquatic organisms called diatoms. These microscopic creatures lived in ancient lakes and oceans, and over millions of years their silica-rich shells accumulated into vast chalky deposits. Today, those deposits are mined from sites across Nevada, California, and the high desert plateaus of Europe and South America. The material looks like fine white talcum powder. Under a microscope, it looks like broken glass. And that is exactly what it is to an insect. Early USDA research in 1939 demonstrated that diatomaceous earth, applied at grain storage facilities, reduced weevil populations by over 95 with no toxic chemical involvement whatsoever. It was cheap, abundant, and safe enough to consume. In fact, food-grade diatomaceous earth was already being used as an anti-caking agent in certain processed foods. And yet, within a decade, the post-war chemical revolution would bury it almost completely. What happened in those post-war years is worth pausing on. Between 1945 and 1960, the chemical companies that had supplied nerve agents and industrial poisons for the war effort needed a peacetime market. Organophosphate compounds, derivatives of wartime nerve agents, were rebranded as agricultural insecticides. DDT, already field-tested on soldiers' barracks, moved into the garden shed. The infrastructure of wartime chemistry became the infrastructure of post-war agriculture. And in that environment, a mineral powder that cost almost nothing and couldn't be owned by anyone simply didn't fit the business plan. But to truly appreciate what we're dealing with, we need to understand how it actually works, because the mechanism is unlike anything in modern pest control. Diatomaceous earth does not poison insects through a biochemical pathway. It does not interfere with their nervous system, disrupt their hormones, or overwhelm their metabolism. Instead, it kills them through physics. And it does so in two distinct ways simultaneously. First, abrasion. The fossilized diatom shells, when viewed under magnification, are jagged, porous, and razor-sharp at the microscopic scale. When an insect walks across a surface dusted with diatomaceous earth, those particles lacerate the waxy cuticle that coats the insect's exoskeleton. That cuticle is not merely decorative, it is the insect's primary defense against dehydration. It is, in a very real sense, their skin and their moisture seal in one. Second, absorption. Diatomaceous earth is extraordinarily hygroscopic. It draws moisture out of whatever it contacts. Once the cuticle is breached, the powder begins wicking fluid directly from the insect's body. The insect loses water faster than it can replace it. In warm, dry conditions, this process reaches lethal dehydration within 15 to 30 minutes. In cooler or more humid environments, It may take a few hours, but the outcome is the same. Think of it this way. Imagine walking barefoot across a field of microscopic broken glass, while the ground beneath you is also pulling the moisture from your skin through every cut. That is the experience of a soft-bodied pest crossing a diatomaceous earth barrier. What makes this particularly elegant is the range of insects it affects. We are not talking about a narrow-spectrum solution. Aphids, spider mites, white flies, thrips, earwigs, fungus gnats, flea beetles, vine weevils, ants, cockroaches, silverfish. The list of documented susceptible species runs well past 100. Any insect with an exposed exoskeleton and a need to retain body moisture is vulnerable. That is, functionally, every crawling or soft-bodied pest in your garden. Here is what makes this remarkable from a practical standpoint. Because the kill mechanism is entirely physical, insects cannot develop resistance. There is no genetic mutation that makes a beetle immune to dehydration. This is in stark contrast to synthetic pyrethroids and organophosphates, where resistance has been documented in over 500 species of insects as of the last major entomological survey. Diatomaceous earth, used consistently, will be just as effective in 50 years as it is today. And consider what that means for the long-term economics of your garden. A single synthetic insecticide product has an effective lifespan, documented in real agricultural practice, of roughly 7 to 12 years before resistant pest populations render it significantly less potent. At that point, the manufacturer releases a new formulation. You buy the new product. The cycle repeats. Diatomaceous earth breaks that cycle entirely. It is a one-time discovery that compounds in value the longer you use it. Food-grade diatomaceous earth typically runs between 80 and 90 amorphous silicon dioxide by weight. It is lethal to soft-bodied insects, beetles, weevils, mites, ants, and slugs, while remaining completely non-toxic to mammals, birds, earthworms, and beneficial soil microorganisms at normal application rates. 1 kilogram of food-grade powder, purchased for under $1 per 100 grams at bulk rates, can treat approximately 30 to 40 square meters of garden bed. So let's look at what the documented record actually shows, because this is not theoretical, and it is not anecdotal. In a 1995 study conducted by researchers at Iowa State University, diatomaceous earth was applied to stored corn bins at a rate of just 500 grams per ton of grain. After 30 days of storage, the treated bins showed a 98% reduction in maize weevil populations compared to untreated controls. The untreated bins, by contrast, had lost nearly 8% of their grain volume to insect damage. The cost of the diatomaceous earth treatment? Approximately 40 cents per ton. The cost of conventional grain fumigation at the same facility? Between 14 and 22 per ton. In Queensland, Australia, the Department of Agriculture formally evaluated diatomaceous earth for smallholder pest management across 47 trial plots between 2003 and 2007. Across different soil types and climate conditions, the trials recorded an average 89% reduction in slug populations and a 94% reduction in aphid colony establishment when earth was applied as a preventive perimeter barrier. The report specifically noted that zero chemical residue was detected in crop tissue, a finding with direct implications for organic certification. It's worth dwelling on that Queensland data for a moment. 47 plots. For years. Multiple soil types, varying rainfall, different altitudes. This was not a controlled greenhouse experiment designed to produce a headline result. It was field research conducted under the messy, unpredictable conditions of actual smallholder farming. And across all of that variation, the effectiveness held. An 89% reduction in slugs under real-world conditions is a result that any commercial pesticide manufacturer would build an entire marketing campaign around. Yet the findings sat largely in the gray literature of state agricultural extension, read by specialists and almost no one else. And then there's the use case that perhaps most powerfully illustrates the technology's reach: the ancient grain stores of Egypt. Archaeological analysis of storage pits in the Fam region has confirmed the presence of fine silica dust, consistent with naturally occurring diatomite deposits, as a deliberate additive to stored grain as far back as 3,000 years ago. The Egyptians, it seems, had independently discovered the desiccating power of this material long before any modern entomologist gave it a name. They used it to preserve harvests across decade-long storage cycles in a climate that would otherwise be a paradise for grain-eating insects. There are also accounts from traditional farming communities in parts of sub-Saharan Africa and the Andean highlands, where locally sourced silica-rich volcanic ash, a natural analog of diatomaceous earth, has been applied to seed storage vessels for generations as a matter of inherited agricultural practice. Nobody taught these farmers the biochemistry of cuticle abrasion. They observed, over generations, that certain dusts kept the insects out. The knowledge lived in practice, passed from hand to hand, long before it was ever written down in a university journal. 3,000 years of field validation, and the average garden center still stocks it behind 40 varieties of synthetic spray. And that's where the story takes a turn. If diatomaceous earth is this effective, this safe, this cheap, and this thoroughly documented, why is it not the first recommendation from every agricultural extension office? Why do the shelves of garden retailers remain dominated by products that cost 10 to 20 times as much per application, require protective equipment to apply, and carry documented risks to soil ecology? There are several real, documented answers, and I think it's worth stating them clearly rather than reaching for a comfortable conspiracy. The first is regulatory categorization. In many jurisdictions, diatomaceous earth occupies a regulatory gray zone. In the United States, for example, it is listed by the EPA as a minimum risk pesticide under FIFRA Section 25(b), meaning it requires no registration to sell, which sounds like a benefit, and it is. But it also means it receives almost no institutional promotion, no agricultural extension funding, and no inclusion in the formal pest management recommendation frameworks that inform what commercial farmers and home gardeners actually hear about. It exists outside the system, so the system largely ignores it. The second barrier is formulation. Unlike synthetic pesticides, which can be emulsified, suspended, and stabilized into shelf-stable spray formats, diatomaceous earth loses effectiveness when wet. This means it requires more attentive application, reapplied after rainfall, kept dry in storage. For an industry built on set-and-forget chemical treatments, that is a commercial disadvantage. The third factor is the profit structure of agricultural retail. A product that costs under $1 to treat a full vegetable bed requires no proprietary equipment and cannot be patented in any novel formulation, does not generate the margin that funds shelf space, advertising, or retailer incentive programs. And that is not a conspiracy. That is just economics. And there is a fourth factor that rarely gets named directly: the education pipeline. The agronomists, horticulturalists, and extension officers who advise both commercial farmers and home gardeners were themselves trained in institutions where the sponsored research, the textbook content, and the career pathways were substantially shaped by the agrochemical sector. That is not an accusation of bad faith. Most of those professionals are genuinely trying to help, but you absorb the world you're educated in. And in that world, diatomaceous earth is a footnote, not a foundation. Here is the quiet truth at the center of all of this. Diatomaceous earth cannot be synthesized in a laboratory in a way that generates a proprietary patent. It cannot be delivered via a subscription program. It cannot be metered, measured out in locked cartridges, or tied to a chemical company's renewal cycle. It comes from the ground. It returns to the ground. And a single purchase, a 5-kilogram bag for under $10, can supply a family garden for an entire growing season. And I think that's the part that most of us never consider. The products that dominate our garden centers were not selected for our benefit by any neutral scientific authority. They were selected by a market that rewards recurring revenue. Diatomaceous earth offers a single sale. And for a retail model built on repeat purchases, that makes it, effectively, invisible. But here's what that actually means for you, because this is where the frustration becomes genuinely useful. Diatomaceous earth is available in 2 primary grades, and knowing the difference is critical. Food-grade diatomaceous earth, sometimes labeled as Codex food chemical grade, contains less than 1 crystalline silica and is safe for use around children, pets, and food-producing plants. This is what you want for garden use. Do not purchase pool filter grade diatomaceous earth. That product has been heat-treated to convert the silica into a crystalline form that is effective for filtration but hazardous to the respiratory system and completely unsuitable for garden application. For garden pest control, the application method matters as much as the material itself. For crawling pests, aphids, beetles, ants, slugs, and earwigs, the most effective approach is a dried barrier dusting applied directly to the soil surface around plant stems and along the edges of beds where insects enter. Apply on a dry day. A light, visible dusting is sufficient. You are not trying to bury the plants. Roughly 200 grams per 10 square meters is the standard application rate documented in university extension trials. For aphid colonies on leaf surfaces, a light dusting directly onto affected foliage during dry morning hours gives the best results. The powder adheres to the plant surface and to the insects themselves, and, crucially, it does not require contact time the way a chemical spray does. The physical action begins the moment of contact. After rain or heavy irrigation, reapply. This is the one genuine limitation of the material, and it is worth planning for. Many experienced practitioners keep a small puffer bottle, the kind used for lens cleaning or bellows dusting, filled with diatomaceous earth near the garden for quick, targeted reapplication. For slug control specifically, a perimeter ring around individual beds, applied at the soil line, is highly effective. Combined with a shallow dish of water to attract and concentrate slugs overnight, you can dramatically reduce a slug population within 3 to 5 days without a single chemical compound. One more practical note: when applying diatomaceous earth in dry, enclosed spaces, a greenhouse, a potting shed, or an indoor grow room, wear a simple dust mask. Not because the material is toxic, but because any fine particulate dust inhaled in large quantities over a long period is an unnecessary respiratory irritant. Outdoors, in a garden setting, the dispersal is sufficient that this is not a concern. But in a small enclosed space with repeated heavy applications, basic respiratory caution is sensible practice. You can find food-grade diatomaceous earth from agricultural supply stores, online bulk suppliers, and increasingly from health food retailers who stock it for internal parasite management in livestock. Prices vary, but 5 kilograms for under 12, enough for a full season's garden treatment, is achievable with minimal searching. In the UK, USA, Australia, Canada, and most of Europe, food-grade diatomaceous earth is entirely legal to purchase and apply without any registration or permit. The solution has always been here. You just needed someone to point at it. An 80-million-year-old marine organism, ground to powder, applied for less than $1, documented in peer-reviewed literature for over 8 decades, and yet most gardeners have never been told it exists. That is not an accident of science. It is an artifact of markets. If knowing that changes something for you, if it shifts the way you think about what you've been sold versus what actually works, then that instinct is worth following. This channel exists for exactly that reason. If discovering these lost, forgotten solutions matters to you, subscribing is the simplest way to make sure the next one finds you. Most people will finish this video, nod, and go back to buying the spray bottle. But you're still here. That tells me something. There is a certain kind of person who, once they learn that a better way exists, cannot go back to accepting the inferior one. Frontier Trapper exists for that person. If that's you, you already know what to do.